Hello, my name is Logan Anderson. I am a member of Group 2, and this is our exercise 5. So, for the first part of exercise 5, we are asked to explain some of the shortcomings of hierarchical clustering and explain the main ideas underlying how the perch system clusters data. So, hierarchical clustering struggles to scale with large data, especially for extreme clustering problems when the amount of clusters is very high. As you can see, we have a little image here showing how that works, and as you would add more points, we would get more complex and more convoluted, and it would be harder to understand. Perch clustering works by taking each data point individually and routing it to the node it is most similar to, and then it creates a new leaf out of that. If this new leaf is dissimilar to the leaf that is its neighbor, so the one right beside it, Perch will actually rotate the node until the leaves that are present and neighboring are similar. Uh, to do this, it creates bounding boxes around each of the nodes of the tree, and then the algorithm will actually use these boxes to determine distances to the new data point, and whichever node it is closest to is the one it will be sent to. For the second part of exercise 5, we're told to explain k-means clustering's algorithm's main ideas, and then discuss some of the shortcomings of k-means clustering. K-means clustering works by determining the closeness of data points to a chosen number of cluster points along a line or a plane. So it can be a single line or a space that we would consider a plane. It then creates new cluster points using the mean between the points located within each cluster, and then reclassifies each point based on which cluster point it's nearest to. So it'll select points, and then whichever of these points that the algorithm selects that the data points are closest to, it will be classified to that cluster. Then, after that point, it will look at all the data points within the same cluster and locate the mean point between all of them. And then it will do the same thing again using these new mean points, and it will continue to do that until the variance within each cluster is the closest to even. So this will be the distance until the total distance from every data point to its cluster point, its mean midpoint, is the closest to even between all clusters. The k-means clustering is not without its shortcomings. A very large one is the inability to create a set of optimal clusters. So it will just do this until it is closest to even in variance. It can't determine which set of clusters would be the most accurate or the best. It also requires a lot of computing power when you're using very large sets of data, and this can be a problem if you don't have a very, very powerful computer. And finally, it's required that the person setting it up actually specifies how many clusters the data needs to be split between, as opposed to the algorithm itself selecting the optimal number. For the final part of this presentation, we're actually going to go over to our SAS Via data program and look at our NBA 2018 data set. So we're going to come over here. For this, I actually decided to settle on 5 clusters. Originally, this idea was because there are 5 positions in basketball, and I wanted to see if it would kind of cluster based upon position. I ended up going with 10 bins, as looking through the different number of bins, I like the distribution of the data on 10 pretty well. And I actually really like the way this turned out. As we can see through our plots up here, we actually have some grouping that makes sense. If we look at our points versus rebounds plots here, you can kind of identify that our cluster 4 would be our considered superstar players with a more guard-oriented play style, as most of our cluster 4 ID, we have some individuals that lie very far along the right, which means they averaged a lot of points. Whereas our cluster 3 would be more of our superstar post players, so our taller and larger players that still scored a good amount of points but also had a lot of rebounds. Our cluster 2 seems to be more of our average players who have a more guard oriented play style. Our cluster 1 seems to be more of our average players who have a more post oriented play style. And our cluster 5 seems to be more like our bench players. This is actually further solidified when we back out and go to our points versus assist plot, because we can see that our cluster 4 is still our very good players with a more guard oriented play style, as they average both a lot of points and a lot of assists, while our cluster 3 still had a very good point average. They did not get as many assists, as most post players tend to do more rebounding and less assisting compared to the guard-oriented play style. And here is our cluster 2, that's the more average player that still has a guard-oriented play style. You can still see that they got a lot of assists and a reasonable amount of points. Thank you.